Hey everyone, Teacher Chang here today, and we're going to classify triangles in the coordinate plane. So let's go ahead and take a look at the different types of triangles that we might have. We can classify our triangles in terms of their angles and in terms of their sides. Now when it comes to their angles, we have three options. We have the acute, right, and the obtuse. So an acute angle or an acute triangle means that we have to have angles that are between 0 and 90 degrees. Okay, so they have to be between 0 and 90 degrees. For a right triangle, we have to have one angle that is equal to 90 degrees. And for an obtuse triangle, we have to have one that is between 90 and 180 degrees. Now we can also determine whether or not our triangles are going to be acute, right, or obtuse by using the Pythagorean relation. Now our Pythagorean relation is our c squared, our a squared, and our b squared. Well, in an acute triangle, that means the Pythagorean relation is going to show that c squared will be less than a squared plus b squared. Where in the right triangle, we have c squared is equal to a squared plus b squared. Now that's the actual Pythagorean theorem. And then in an obtuse triangle, c squared will be greater than a squared plus b squared. Now we got to remember that the c value in these triangles must be the longest side. So that's going to be the hypotenuse when it comes to that right triangle. Well, it's going to be the longest side when we go ahead and compare the sides in an acute and obtuse triangle as well. Now, in terms of the equilateral triangles, the isosceles triangles, and the scalene triangles, that all has to deal with our sides. Now, an equilateral triangle basically means that all sides are congruent. So all three sides will be exactly the same. Now, in an isosceles triangle, only two sides are going to be congruent. And in a scalene triangle, that means no sides will be congruent. Now, the equilateral triangle has to be an acute triangle because in an equilateral triangle, all three angles are going to be 60 degrees. Now, in an isosceles triangle, they could be a right, an acute, or an obtuse triangle as well. Scalenes could also be acute, right, or obtuse. So we want to be able to classify these triangles by being as specific as possible. So if it's an isosceles triangle, well, is it an acute isosceles, a right isosceles, or an obtuse isosceles? So that's what we want to do when we're classifying our triangles. We want to be as specific as possible. Now, in order to do that, we want to be able to check out our sides, and when we check out our sides, we want to be able to use either the distance formula or the Pythagorean theorem. We're going to be doing both today when we take a look at a couple of problems. And when we take a look at the angles, again, we're going to use the Pythagorean relations in order to check to see if it's a right triangle, an acute triangle, or an obtuse triangle. So let's take a look at our first example. Here we have triangle ABC, and it's given to us on a coordinate plane. What we want to be able to do is to figure out, okay, well, what do we know about this triangle? And then be able to classify this triangle as specific as possible. So the first thing that I'm going to do is I'm going to take a look at these sides here. And I'm going to go ahead and take a look at this first side, AB. So I'm going to take a look at this side right over here. And I want to know, okay, well, what is the length of that side? Now, I'm going to go ahead and do this using the distance formula for this particular side. Now, we could go ahead and use the Pythagorean theorem, but I'm going to show you both. So for this first one, I'm going to use the distance formula, and that distance formula is d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we're going to use the distance formula, which means I need to know the ordered pairs of A and B. So point A is going to be located at -5, 4. And point B looks like it's located at 4, 1. So what I'm going to do is I'm going to assign my x1s and my y1s for point A, because that's my first point, and my x2 and my y2 for point B, because that's my second point. And all we got to do is substitute. We plug and play. So I'm going to substitute this information in here. And that means D is equal to the square root of x2, which is 4, minus x1, which is negative 5, so that means plus 5, squared, plus y2, which is 1, minus y1, which is 4, squared. And then we go ahead and do the math here. Well, 4 plus 5 is 9, and 9 squared is 81. 1 minus 4 is negative 3, and negative 3 squared is 9. And all of this is still inside that radical. Well, 81 plus 9 is equal to the square root of 90. Now, I could go ahead and simplify this, or I could go ahead and put it in decimal form. But I'm just going to leave it like this because I just want to see if this is going to be congruent with anything else. So we do know that the length of AB is the square root of 90. So now I want to go ahead and check out, okay, well, what about BC? So I want to figure out, well, what is the length of BC, the distance of BC? So I'm going to go ahead and do this one a little bit differently. I'm going to go ahead and use the Pythagorean theorem. So for BC, I'm going to go ahead and draw a right triangle. And when I draw that right triangle, I'm going to be drawing these horizontal and vertical lines here so they connect and create a right triangle, where BC is going to be one of my 3 sides. So if I go ahead and draw this right triangle here, I can see that this length right here is 3, and this length over here, it looks like it's going to be, well, we got 8 here plus 1 more, so that's 9. Okay, so we got a 3 by 9 triangle. So that means if I plug it into my Pythagorean theorem, a squared plus b squared is equal to c squared, well, I'm obviously missing that hypotenuse. So I'm going to go ahead and calculate what that hypotenuse is. So that means 3 squared plus 9 squared is equal to c squared. Well, 3 squared is 9. 9 squared is 81. And that's equal to c squared, which means 90 is equal to c squared, which means c is equal to the square root of 90, because I got to square root both sides to get c by itself. So we can see that already AB must be congruent to BC. So we already have at least an isosceles triangle. So I know that these two angles, or these two sides, are congruent. Now I need to go ahead and figure out that last side just to be sure. So I'm going to go ahead and calculate, okay, well, what is the distance from A to C, or C to A? So let's go ahead and try that one out, and I'll go ahead and call that AC. And I like doing the Pythagorean theorem, so I'm going to go ahead and draw that right triangle again. I'm going to use the Pythagorean theorem method. If you prefer to use the distance formula, by all means, go for the distance formula. You just need to write out the ordered pairs, plug in your x1, your y1, your x2, and your y2, and in the end, we should get the same thing here. Okay, so now that I have these, we're going to go ahead and figure out the distance of each of these sides. So over here on the bottom is going to be 6 units wide, and going up and down, that looks like it's going to end up being 12. So if I plug it into our formula, a squared plus b squared is equal to c squared, well, that means, well, a is 6 squared plus 12 squared is equal to c squared. That gives us 36 plus 144 is equal to c squared. And 36 plus 144 is 180. So now I got 180 is equal to c squared, which means c is going to be the square root of 180. So that's obviously different from the other ones. So we do know that this has to be an isosceles triangle. We have 2 sides that are congruent, and those 2 sides is AB and BC. Now, I'm not 100% sure about this angle right over here. Is that angle a right angle? I'm not 100% sure. So what we're going to do is we're just going to go ahead and take the longest side, and that longest side that we have here is this square root of 180, and we're going to go ahead and check our Pythagorean relation. So I'm going to do our Pythagorean relation to check to see if it's an acute, obtuse, or a right triangle. So that means c squared is either going to be greater than, less than, or equal to our a squared plus b squared. Okay, so when we take a look at this, let me go ahead and minimize this. So when we take a look at this, we do know that the longest side is that 180. So that's going to give us the square root of 180 squared, which is just 180. Okay, and then we have the other two, which is 90. So that means we're going to do our a squared, or the square root of 90 squared, which is just 90, and the square root of 90 squared again is also 90. And well, if we add those together, well, guess what? They are exactly the same. 90 plus 90 is 180 degrees, or 180. So that means since these two are equal, we know that this is going to be a right triangle. So we know that it is an isosceles. It is also right. So we can classify this as a right isosceles triangle because two sides are congruent. So we can go ahead, actually, let's go ahead and name those two sides. So we can say that this is a right isosceles triangle because AB is congruent with BC. And we know it's a right triangle because it does meet that requirement of a squared plus b squared equals c squared. So that's our first one. Okay, it's a right isosceles triangle because AB is congruent to BC, and we've also proven using our Pythagorean relationship here. Okay, let's go ahead and try this next one. Except this next one's slightly different because, well, they didn't give us the coordinate plane. So what we're going to do is we're just going to use these coordinates to figure out, okay, what type of a triangle do we have here? And in order to do this, well, we got to go ahead and do the work. We got to go ahead and use the distance formula. I can't use the Pythagorean theorem anymore because I don't have that graph. So I'm going to go ahead and classify, I'm going to figure out the length of each of these sides. And in order to do that, I'm going to go ahead and start off with my first side being GH. Change that back. Okay, so GH is going to be my first side, and that first side will have the ordered pairs of -4, 0, and 4, 0. So G is -4, 0, H is 4, 0. And we're just going to plug it into our distance formula. Remember, this is my x1 and my y1, this is my x2 and my y2. And if we plug it in, okay, and that means it's going to be x2, which is 4, minus x1, which is -4, so that means plus 4, squared, plus y2, which is 0, minus y1, which is also 0, squared. Well, 4 plus 4 is 8, and 8 squared is 64. And, well, 0 minus 0 is 0, and 0 squared is still 0. And 64 plus 0 is just 64. So we have the square root of 64, which is just going to bring us back to 8. So the length of GH is 8. Now we're going to go ahead and take a look at our next side. And our next side is going to be from H to I. So HI has the ordered pairs of 4, 0 and 0, 4 root 3. And again, this is my x1, my y1, x2, and y2. And I'll just go ahead and plug all of this into my formula. So D is equal to x2, which is 0, minus x1, which is 4 squared, plus y2, which is 4 root 3, minus y1, which is 0 squared. Okay, well, 0 minus 4 is -4, and square that, that's going to give us 16. And 4 root 3 minus 0 is just 4 root 3, and you square that, and that's going to give us 48. And we still have the square root sign. Well, 16 plus 48 is equal to 64. So now we got square root of 64, and that's also equal to 8. So we know it's at least an isosceles triangle. All right, well, let's go ahead and try that other side, and just to see if we have an equilateral triangle. So if we get another 8, we got an equilateral triangle here. So we have GH, HI, and now I got IG or GI. Okay, so that's my third side. Now, I is going to be at 0, 4 root 3, and G is going to be at -4, 0. And again, I'm just going to substitute it into my formula, the distance formula. So D is equal to the square root of, and remember this is my x1, y1, x2, y2. So x2, negative 4, minus x1, which is 0 squared, plus y2, which is 0, minus y1 squared, which is 4 root 3. Okay, so now we'll do the math. Negative 4 minus 0 is negative 4. Negative 4 squared is 16. And 0 minus 4 root 3 is negative 4 root 3. And you square that, and that's also 48. So now we got 16 plus 48, which is once again 64. And well, the square root of 64 is also 8. Now, since all three of these sides have the length of 8 units long, then we know it has to be an equilateral triangle. Now, we don't need to classify if it's a right triangle or an obtuse triangle because we already know that in an equilateral triangle, it has to be an acute triangle because all three angles are going to end up being 60 degrees. So that you don't need to prove. All right, I hope this helped out. Go ahead and use the distance formula or the Pythagorean theorem to help you classify the length of each of these sides. And then in terms of acute, obtuse, or right, go ahead and use the Pythagorean relation. I hope this helped out. Leave a comment. If you have a question, go ahead and subscribe. Give me a thumbs up, and I'll catch you on the next one. Good luck, enjoy, and have fun.